Then we come to compressible flow versus incompressible flow. Compressibility and incompressibility again are very familiar term. A fluid is classified as being compressible or incompressible depending upon the level of variation of density during a particular fluid flow phenomena. तो आप जिस तरह के जानते ही हैं, most of you would know, there are a lot of elements, incidences, चीज़ें कि जिनकी डेंसिटी चेंज नहीं होती इजीली. तो जिनकी चेंज नहीं होती नॉर्मली वो लिक्विड्स को में देखा जाता है. लेकिन अगर आप गैसेस देखें, नो मैटर विच गैस, देन इट इज सब्जेक्ट टू चेंज इन डेंसिटी if you apply forces on that. External force apply करें, pressurize करें, then it reduce in volume, but then its density will increase, or vice versa in the other direction भी यही चीज हो सकती है. Therefore, the volume of every portion of fluid remains unchanged over the course of motion. This is for fluids, or that is why we normally would like to call them as incompressible. Mostly that is the condition that prevails for liquids. The densities of liquids are essentially constant, and thus the flow of liquids is typically incompressible. Gases, on the other hand, are highly compressible. When analyzing rockets, spacecrafts, and other systems that involve high-speed gas flows, the flow speed is often expressed in terms of dimensionless Mach number, which we defined as ma equal to v over c, where v is speed of flow and c is speed of sound. So when these two things are equal, the Mach is equal to 1, and such a flow is known as sonic, a sonic flow. But if Mach number is less than 1, we call it subsonic flow, and if Mach number is greater than 1, we call it supersonic flow, and if Mach number is much greater than 1, then it is called as hypersonic flow. तो आजकल आप देखते ही होंगे, जैसे कई अक्सर फाइटर एयरक्राफ्ट्स, हमारा थंडर 117, F-16, ये वो एग्जाम्पल, या मिराज इवन, ये वो एग्जाम्पल्स हैं जो सुपरसोनिक स्पीड के ऊपर फ्लाई कर सकते हैं. और ऑन दी अदर हैंड जो हमारे नॉर्मल कमर्शियल एयरक्राफ्ट्स हैं वो सबसोनिक स्पीड के ऊपर चलते हैं, और वेरी रेयरली एक आधे एयरक्राफ्ट बना भी था, लेकिन फिर वो बाद में उसको ख़त्म कर दिया गया. लेकिन बहरहाल फाइटर एयरक्राफ्ट्स में ज़्यादा तेज़ स्पीड की ज़रूरत होती है, वहाँ बनाए भी गए हैं, और कमर्शियल स्पीड में फिर ये टेक्नोलॉजी इतनी महंगी है कि वो इकोनॉमिकली वायबल नहीं रहते. Liquid flows are incompressible to a high level of accuracy, but the level of variation in density in gas flows, the consequent level of approximation made when modeling gas flows as incompressible, depends on Mach number. So compressibility very much depends on this number. Gas flows can often be approximated as incompressible if the density changes are under about 5%, which is usually the case when Mach number is less than 0.3. So you can see an estimate there for the scientist when they can consider a certain flow as incompressible. लेकिन अगर ये जो एक क्राइटेरिया रखा हुआ है, अगर ये ब्रेक होता है तो फिर then we cannot consider the fluid flow as incompressible. Therefore, the compressibility effects of air can be neglected at speeds under 100 meters per second, but when it is higher than that, based on that criteria, ये जो है ये related है with ma is less than 0.3 and the speed is about 100 meters per second, तो उसे हम incompressible कर सकते हैं. हालांकि we know that air is not incompressible fluid. Air is compressible, लेकिन for the sake of calculation they are considered to be good enough. And flow of gas is not necessarily compressible, मैं mention कर चुका. Small density changes of liquids corresponding to large pressure changes can still have important consequences. तो वो हम we understand that. और MA अगर 0.3 से कम भी हो, उसके ऊपर अगर हम एक्सटर्नल प्रेशर्स अप्लाई करेंगे, फोर्सेस अप्लाई करेंगे, तो नेचुरली इट्स कंप्रेसिबिलिटी इफेक्ट होगी, इस डेंसिटी इफेक्ट होगी. बहरहाल ये जनरली ब्रॉडली स्पीकिंग एक कैटेगरी थी बिटवीन दी कंप्रेसिबल फ्लूइड एंड दी नॉन कंप्रेसिबल फ्लूइड और उसकी यूटिलिटी जो हम आम लाइफ में करते हैं.